Hi there, my name is Karen, and in this video we will be beginning our chapter on factorization. So this is chapter 11 of our 8th grade math course, and welcome back to Through Inquisitive Kids. Throughout this unit, we will be learning all about factorization, and in this lesson, it'll be sort of our introduction where we will be understanding the definition of factoring polynomials. Now, before we go into the lesson, I want you to think of factorization as a series of steps we do to simplify an expression or polynomials. So just like removing denominators or combining like terms. It's not exactly an operation, it's more of a series of steps that help us get from one form of a polynomial to another. But don't worry if you don't completely understand yet, that's what we're going to cover just in this lesson. So this unit is going to be pretty short. We have our first lesson, factorization, and then we have 2 more lessons, each with its own parts. So altogether, we'll have this video, 2 more videos under the second lesson, and 2 more videos under the last and final lesson. The learning goals of today is to understand the definition of factorization and to understand the connections and differences between factorization and multiplying whole expressions. Multiplying whole expressions is something we have touched on in earlier chapters, so if you think you need to go back and review that, or maybe you haven't watched it yet, I will be linking its link in the description down below. Anyways, let's do some review for our introduction. Question: what numbers divide evenly into 21? Well, this should be pretty simple, 1, 3, 7, and 21. And how did you get those answers? Well, because we know that 21 is equal to 1 times 21, and it's also equal to 3 times 7. Looking at the previous 2 questions, let's think. Since some numbers can be factored, can polynomials be factored as well? Throughout your math career in middle school, you have been discovering how things that we can do to numbers can be applied to expressions and variables and polynomials as well. So you can think of factorization as factoring polynomials. The answer to that is definitely. So first, what is the concept of factorization? Is 99 to the third power minus 99 divisible by 100? Well, the way to solve this problem is to first simplify this expression in a way so that we can see it turned into something multiplied by 100. So here would be that series of steps. We start with this expression, and then we can turn it into 99 times 99 squared minus 99 times 1. Now factoring out that 99, which is its common factor, we have 99 times the difference between 99 squared and 1. And now using our squared difference formula, we have 99 times 9,800, which is equal to 98 times 99 times 100. So 99 raised to the third power minus 99 can be divisible by 100. What other integers is 99 raised to the third power minus 99 also divisible by? As shown, a vegetable garden is split into 3 sections. Can you use different formulas to represent the area of this vegetable garden? So we have a shared width, which is m, and then we have the length split into 3 different segments, A, B, and C. And looking at this reminds me of when we were just starting to learn about the distributive property back in elementary school, right? But that's when all of these variables were still numbers. We can represent this area in 2 different ways. The method 1 is m times the sum of A, B, and C. And method 2 is MA plus MB plus MC. So these 2 expressions represent the same value. It's just looking at it from different perspectives. So here we can connect that m times A plus B plus C is equal to MA plus MB plus MC. Going from the left side to the right side, we are multiplying whole expressions. M itself is a whole expression, and the sum of A, B, and C is also its own whole expression. But going the reverse way, what do we call it? Let's do an exercise. Complete the following blanks. Now I want you to pause the video and fill in the blanks. So this should be pretty simple. Using the distributive property, you can fill in these blanks. So it would look like x squared minus 2x, x squared minus y squared, and x squared plus 2x plus 1. And you'll see that all of these are using formulas that we have learned before. Now, according to these previous blanks, can we fill in the parentheses? Now you'll see that it's just the reverse operation. We have x times x minus 2, x plus y times x minus y, and x plus 1 squared. Observe the similarities and differences between the two sides of the equations. So what is the difference and similarities between these two sides of the equation? Well, here are the similarities. Both sides are versions of the same polynomial, but the differences are that the left side is of two polynomials being multiplied together, while the right side is already distributed. So the left side, as you can see, is two polynomials being multiplied together. X plus y is its own polynomial, so is x minus y. But on the right side, it's already factored into one polynomial, which is x squared minus y squared. So those are its similarities and differences. Now question 2. The right side shows the factorization of polynomials. Can you define what factorization is based on our analysis? So using your observations, here's what you can conclude about factorization. Turning a polynomial into the form of the product of several whole expressions is called factorization. Each factored whole expression is the factor of this polynomial. So the two keywords here are factorization and factor. Going back, the process of turning this left side here into the form of two expressions being multiplied together, this process is called factorization. It's different from this process where we are multiplying whole expressions. Multiplying whole expressions is something we have covered earlier. Now we are learning its reverse, which is factoring polynomials. Now each of these parentheses would be the factor of this polynomial. Check if the following transformations are factorization. Now I want you to pause the video and using the definition we learned about factorization, determine whether if these are factorization or not. So the first one should be x, so these are all not factorization. C is factorization, D is not, E is not, and F is not either. So here's how we can find if it is a transformation. 3 things. If the left side is a polynomial, if the right side is in factored form, so this is what we call factored form. If it's in this form right here, then it is in factored form. And if the factors on the right are all whole expressions. Let's do another exercise. Simplify these following expressions using the distributive property. Alright, so here should be your answers. Check them on your own. And then now fill in the blanks according to the previous questions that you solved. So as you can see, this is just the reverse order, but now instead of multiplying whole expressions, we are factoring this polynomial. So this becomes 3x times x minus 1, m times a plus b plus c, and so on. So it's just reversing the order. Comparing factorization and multiplying whole expressions. How did we get from a times a plus 1 times a minus 1 to a cubed minus a? And how did we get from a cubed minus a to factored form? Now I want you to think about that for a moment. So here's our explanation for that. From factored form to polynomial form, we multiplied whole expressions. And from a cubed minus a to factored form, we did the previous's reverse operation, which would be factorization. Multiplying whole expressions and factorization are reverse operations. Now, I don't really like saying the word operation because it's not necessarily, addition, subtraction, multiplication, or division. But by operations, I'm just trying to say that it's a series of steps that you do to get from one form of a polynomial to another. So from this form to this form, we do factorization. But the other way to get from factored form to this form, we do multiplication of whole expressions. So x squared minus 1 is equal to x plus 1 times x minus 1. The left side is a polynomial. The right side is the product of multiple expressions. Let's do some practice. Out of the following options, which one can be factored into this form? Well, we have to look at each of these options and we will get B. So how did we get B? You can see that we can use a formula right here. X plus y, remember the formula a plus b times a minus b is equal to a squared minus b squared? That's what we can get here, x squared minus y squared. But remember, we still have to multiply that negative sign right there. So instead of x squared minus y squared, we have negative x squared plus y squared. So here is our class summary. Today we learned all about factorization. Its definition is that factorization is the process of transforming a polynomial into the form of the product of several whole expressions. Each whole expression is a factor of the polynomial. We also learned about the multiplication of whole expressions, its relationship with factorization. They are opposite operations, and that factorization converts a polynomial into the form of several expressions being multiplied together, while multiplication of whole expressions converts the product of several whole expressions into a polynomial. So again, they are reverse operations. Now this slide, every slide that we have will always have a class summary, and this is usually a good time to conclude everything you've learned in the lesson. And if you do take notes, which I highly suggest that you do so, take notes because it's already usually organized in this visual mind path. Again, to recap, today we understood the definition of factorization and we understand the connections and differences between factorization and multiplying whole expressions. Again, multiplying whole expressions and multiplying whole expressions is something I will be putting in the link down below. So if you think you need to recap on that, then I definitely support you to do so. Again, thank you so much for watching 3 Inquisitive Kids. If you found this video helpful or you learned something new from it, please make sure to hit the like button, and for more videos like this, be sure to hit that subscribe button as well as the notification bell. Thank you so much for watching 3 Inquisitive Kids, and we'll see you next time.